All right, it's recording. Let's go. So, what is 3F about? 3F is about terminating and recurring decimals. So, the part of your notes with your pen or pencil, let's write this in. So, terminating means that the number has finite decimals. What does finite mean? Can I please have? Let's go with Osman. What does finite mean?
It means that
Not sure. Okay, that's all right. I'm just asking around just to get a sense of what we know. So terminating decimals means it has finite decimals, but we need to know what the word finite means. Harrison.
Like it stops at a certain point.
Good. It stops. It's limited. Okay. It's not unlimited. When we say infinite means it's unlimited. Okay. So for those who aren't sure what these terms mean, just write on the side so that you know. What are some examples of finite decimals? So let's have a look. One example, I'll give you one and then you give me one, okay? So here we go. An example of a finite decimal is something like 3.5, so 3.5. Okay, it doesn't go on, it's just 3.5. Just like your shoe sizes, 10.5, 10, 9.5, 9. Doesn't have 9.3, even though that's technically still terminating, but it stops, it doesn't go on. Give me an example of a terminating decimal. Can I please, let's go with Lewis. Give me an example of a terminating decimal or finite decimal. I gave one. 3.2. 3.2. We got 3.2 is a terminating one. Give me another one. Let's go with Ava. 5.7. That works. You don't have to have just one decimal as well. It could also be, say, 6.12. Okay, it can be a bit longer. Give me another long one. Let's go with Tiana. Give me a long one. That's terminating. 7.12. Yeah, 369. This is an example. This is an example of terminating because it stops. Okay, so it can be as long as it needs to be, but if it stops, that's called terminating. Recurring, though, that's what the next term is. Good. So Fraser's got it. So he said 3.3333. Now, I don't want to sit here and write 3 infinitely. How do we show that it is recurring on just the 3? Good. We can do a dot. And what's the other way as well? You can do a dash or a line. Okay, so they call it a bar. So you can do dot. You can do multiple dots. So you can do like 3 and 3. So that's essentially saying they come together as 3. You could also do a bar across the numbers that repeat, but you only put it on where it repeats. Okay, in this particular case, because it only repeats on the 3, then we only need to put a dot on 1 3. Okay, and then we just...
Can you just pick any of those?
Ideally, once you put a dot, you don't need to put 3s afterwards. Yeah. So that way people know that means I'm going to write 3. That's right. And if you did happen to write extra 3, so let's say you did 3, then put the dot on the very last digit. Okay? Thanks, team. Don't speak while I'm speaking. All right. So that's an example of a recurring decimal. What's another recurring decimal that you can come up with? Let's go with Hamish.
6.6666.
6.6666. Yes. And again, I can put a dot on the 6. I want to use a bar this time. So we're using examples where it has dots, but I want one where you use a bar. Can you come up with one that we can use a bar? Let's go with Sam.
Can you do like 7.1222222?
So it's repeating on the 2?
Yeah.
I want one that repeats more than just one digit.
10.
So 1 0.
1 0 and then
So 1 0 1 0 like this?
yeah.
Okay. Now if you want to repeat as 1 0 1 0, you can do, listening, please don't speak while I'm speaking. You can do a bar on the 1 0 to mean that it repeats 1 0 1 0. You could do 2 dots to mean it repeats the 1 0 1 0. But when I ask you to do multiple ones, essentially I can say something like this. You can write 4.12783 and put a bar on it. And that just basically means it'll be 4.12783, 12783, 12783. Yeah, so I'm trying to highlight to you that you can have stopping versus infinite. See the difference? What you're used to seeing is that what you see in the textbooks, they often do just one decimal. I'm trying to teach you that it can be multiple decimals. It doesn't have to be 3.2, 5.7, 10.1, 9.8. Okay, it can be 6.12. It could be 7.12369. Okay, those are all finite. These are all infinite. Cool? So today's lesson, it is to then determine which one is terminating, which one is recurring if you have a fraction. Because it's easy to tell when you have numbers or decimal system, but what if you don't have a decimal system? So here's an example. Let's do the first one. The skill today is to see if you can convert something like 5/8 or 6/7 into a decimal. Oh yeah, I just realized that is totally by accident there. To convert that so that you know whether it's terminating or recurring. Here we go. For those who don't know, 5/8. What's that symbol mean again? What's this symbol? Divide. So if you're not sure how to do this by hand, you can use a calculator, but what you type on the calculator is 5 is the numerator. This symbol means divide, and then you're dividing by 8. Don't do it the other way around. If you type 8 divided 5, it's a totally different answer. Yeah? So this one, you're actually saying how many 8s fit into 5? Well, your calculator should be 5 divide 8. Now, without using a calculator, we're going to do it by hand first, and then we're going to check it on a calculator to see if it's right. To do it by hand, we're saying how many 8s fit into 5? So 8 goes on the outside, 5 goes in the inside, but I'm going to change it to a decimal. So 5 as a decimal is 5 units, 0 tenths, 0 hundredths, 0 thousandths, and you can put in as many zeros, place values as you want or is needed. Let's work it out. Let's see if you remember your short division here, or long division. I do short division just to make it quicker. How many 8s can fit into 5? Can I please have Steph? How many 8s can fit into 5? 0. So what do you do after you put a 0, Rylan? Very good. So you take the 5 units, which we know is equivalent to 50 tenths. That's why they put the 5 over here. But don't forget, that's in the tenths column, so you have to put a decimal point. This is now 50 tenths, which is equal to 5 units. So we move the 5 across. How many 8s into 50 tenths? 6 remainder what, Fraser? 2. Very good, because 6 times 8 is 48. And that's 50, so it's a remainder of 2. So we carry the 2 tenths, which equals to 20 hundredths. That's why the 2 goes over here. So that's 20 hundredths. How many 8 fits into 20? Lennox?
2.
2 remainder? What's the remainder? 4. So we carry the 4 from hundreds to the thousands. Now that's 40 thousandths. How many 8s into 40? Let's go with Vivian. How many 8s into 40? 5. Beautiful. Remainder? 0. And that's why there's nothing else to carry on from here. Okay, so 0 remainder, it stops there. So is this terminating or recurring? Can I please have Rory? Is this decimal now, 0.625, is that terminating or recurring?
Recurring.
No. Recurring, it's good. I'm testing if you're listening, that's why. So, now don't listen to what others say. Sam, turn around. Thank you. Terminating's here, so just looking at your notes. Terminating is when it's finite. Finite means when it stops. Yeah, so make sure those are in your notes. Recurring means it repeats. So then it keeps going. Yeah, so in our case, it's not repeating. It stops at 0.625. So the answer is then terminating. Very good. Write that down. No, don't let them change your mind. If you're absolutely sure, that's how I know that you actually know what you learned. Okay, so write this down. Write as part of your notes. Let's go. Next one. 6/7. If I were to type this in my calculator, what do you type on your calculator? Let's go, Quinn. 6 divided by 7. Very good. Shh. Thank you. Settle down. All right. If you weren't sure how to do it by hand, you can do it on a calculator. You can actually type 6 divide 7 and you will get your decimal, just whether you do it right or not. Some students will write it the other way around, and you got to pick up when it's wrong. Yeah? So it's 6 divide 7, and let's see. How many 7s fit into 6? 6 point, and again, I can put as many zeros as I need. Let's calculate it. How many 7s fit into 6? Let's go with Joshua. Can 7 fit into 6?
No.
No, because it's too big.
Yes.
So then we put?
Remainder, right?
Good, yeah, we put the remainder. What's the remainder?
The remainder would be...
Yeah, very good. Yeah, it'll be 6. Correct, because 7 can't go into 6. So we say 0 times. Thanks, your rates. Don't speak while I'm speaking. And yes, you carry the 6 over, so this becomes now 60. How many 7s fit into 60? Can I please have, next person. Yeah, Shakira. How many 7s fit into 60? Yes, you're right. 7 times 8 is 56. Remainder what? 4. Good. So we carry the 4 across. And then that's 40 now. So we now ask ourselves, how many 7s fit into 40? Let's go with Harrison. Yep. 5. Very good, because 7 times 5 is 35. That means closer to 40. We're missing 5 units, so carry the 5 over. And I get now 50. So we've got to keep going. Let's go another one. How many 7s fit into 50? Thajas? 7. 7 times 7 is 49. That's 50, so remainder 1. Carry the 1 across. Let's go with the next person. Sophie, how many 7 goes into 10? 1 remainder? 3, very good. We carry the 3 across and we're still going. 7 goes into 30. How many 7 fits into 30? Let's go with Mark. 4 remainder? 2, because 4 times 7 is 28, so we've got remainder 2. And that's now a 20 there, so we carry on. How many 7 fits into? 20. 2 remainder 6. Woo, look at that. And we're back to 6-0 again. So we say, how many 7s fit into 60? It's recurring, very good. So Fraser picked up that since you've got this 60 again, it's going to end up being 8.
So you can never find the same number.
No, it'll be 8, 5, 7, 1, 4, 2, and it'll carry on. So instead of writing this, we can write a bar on top to say these are the numbers that are going to repeat. It's going to be 8, 5, 7, 1, 4, 2 as your answer. So therefore, is this terminating or recurring? And Fraser, you said? Recurring. Very good. Copy that down. I'm going to quickly grab out the calculator to show you what to type, especially if you're not very confident with doing this by hand.
After that, can you get
You got to learn how to do some rounding first, and then you can. Yeah. After all the notes.
When's 3 saved you?
Week 5.
Oh, so 3 saved you next. I don't have
All right, your rates. Eyes and ears towards the board. Shh. Settle down. Thank you. Here we go. So 6 divided by 7. You can see it carries on. Can you see the pattern? It becomes 8, 5, 7, 1, 4, 2. And then again, 8, 5, 7, 1, 4, 2. And it carries on. That's called recurring. Okay. Next one. The other one we did was 5 divided by 8. And it stops. 0.625. But you see the difference if I had swapped it around. If I didn't do 5 divide 8. But if I did this. If I did 8 divide 5. That's totally different. Yes, it's terminal. It's terminating. That's a totally different answer. Because that's asking, if you type 8 divided by 5, you're asking how many 5s fit into 8. And 5 can fit into 8. Once at least. That's why it's different. That's why it matters when you type in your calculator, do you understand what 6, where the numerator should go, divided by 7, what that actually means? Yeah, so if you type in your calculator, make sure to type it correctly. I do want you to practice your long and short division skills first. As you get better at it and you're pretty good, use a calculator to check your answers. Yeah? Now, there is a little tip for you to think about. There is a quick way that I'm going to give you as a tip. And I'm just curious if you guys picked it up just by looking at the fractions. You see the fractions I gave you? I chose them very specifically. There is a quick way to determine, just looking at a fraction, whether it's going to be terminating or recurring. Look at the fraction I gave to you so far. I've given you 5 over 8, 6 over 7. 5 over 8 turns out to be finite. So the 8 is key. 6 over 7, it actually doesn't matter what the numerator is. This one ended up being infinite. Does anyone know what other ones that are recurring that you can tell just by looking at the denominator? Here's an example. 1/3. What's that as a decimal? Anyone know? Very good. So that's recurring. So that means a denominator of 7, a denominator of 3 ends up being infinite. But let's say half. Is that infinite or finite? Finite, because we know half is 0.5. Now, I've given you now some hints here. There's an 8, there's a 2, there's a 3 and a 7. And I know most students are going to jump the gun and they're going to say something, but I'm going to think fit before you answer the question. If I gave you 1 on 11, will this be recurring or terminating?
Recurring.
It is going to be recurring. Why?
Because it's a prime number.
Oh, that was the key thing. Yes, because it's prime. Can I get a show of hands who actually thought it was odd? Get a show of hands if you thought it was odd. Okay, so the pattern that I gave to you, 3, 7, it almost feels like every time you have an odd number, it's going to be recurring. It's not actually whether it's odd, it's actually about what Harrison just said there. It's prime. Why? Here's an example. What's 1/5 as a decimal?
0.2.
Yeah, that's terminating. But that's an odd number. That doesn't make it recurring. The only time, here, write this as part of your notes, everyone. Your rates, to quickly know if a fraction is going to be terminating or infinite or recurring, the tip is if the denominator is a 2 or multiples of 2 or 5, then it will be terminating, always. Doesn't matter how. For everything else, for it to be recurring, it's not about the number, it's about the prime number. It's every other prime number. Every other prime number will be recurring. So for example, 3 is a prime number. 1 over 3 is going to be recurring. 1 over 7 is going to be recurring. 1 over 11 is going to be recurring. Think about all the prime numbers. Yeah? And if it's not 2 or 5, okay, if you break those factors down like 12, you break it down, you've got a 2. And wait, 12 is 2 squared times 3. You got that 3 there. That then eventually becomes, the half becomes the finite part. So for example, here, if I get 1 divided by 12, you see how every other prime factor, okay, every other number, if it's not 2 or 5, multiples 2 or 5, it ends up being recurring. Get me? Okay, so that's a quick way of seeing it. So you're looking for the prime factors. If it's prime factors of 2 or prime factors of 5, then it works. Okay? So here's an example for those who don't understand what I'm saying. 1 over 12. See, 12 is not a prime number. But if you break the 12, that's 1 over 3 times 4. 1 over 3 times 1 over 4. See, that's recurring. You take a recurring one, times by, even though that's multiples of 2, that recurring will make it recurring. So that's what you're looking for. You're looking for the prime numbers. Okay, look for the prime numbers. Now, do you need to know this? This is at a high level. If you get it, great. If you don't, memorize that. And if you don't, I guess you can do long division and get there. All right? Yep.
7 times 6 equals 1 times 6.
6 times 1.6.
Oh, sorry, 7 divided by 6.
7 divided by 6. Well, 7 divided by 6. 6 is a, it's not a prime number. But it breaks into 2 and 3. 3 is recurring. So then it should end up being... Sorry? Only 2 and 5 are recurring, but it can be multiples of 2. It has to be powers of 2. So like 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. So any denominator of 2, 4, 8, 16, 32, those will be finite. But anything else will be recurring. All right, team. 6 shouldn't be. Because 1 6 is equal to 2 times 3. And then that's a problem. See that? So 6 can be broken up into 2 prime numbers. That's a half times a third. This is finite. So then you times it by something that's infinite. So an infinite times something finite will always be infinite. Wouldn't be. So we did 1 divided by 6. So it goes on. That's how you know. All right, year 8s. Thank you. As this towards the board. Thank you. Thank you. Now I know that what I just introduced there is a bit higher, so I can see why you might have checked out on that. We're going to focus on the last example for today, and then you have some time to work on either exercise 3C or 3E, and if you're up to date, there'll be 3F. Okay, here we go. Last example that I need to know that you know is, can you round... Rory, my 3 rules. Rule number 1, don't speak while I'm speaking. Rule number 2, don't speak while someone else is speaking. What's rule number 3? Thank you. You broke rule number 1, don't speak while I'm speaking. Yeah? Actively listening or taking notes. Okay. All right, here we go. So example 3, I need to know that you know how to round decimals to 1, 2, 3, or to the closest whole number. So the first skill was to see if you know it's terminating or recurring. Second skill is, do you know how to round the decimals correctly? So here we go. I've given you A, B, and C as scenarios, but then you've got round to 1, round to 2, round to 3 decimals. The key rule is, if the decimal you're looking at is 5 or higher, then you always round up. Otherwise, you round down. Second warning, yeah? Here we go, 12.3845, so here we go. Let's round to first decimal place. So when we say round this to the first decimal place, what they mean is right after the decimal point, pick the first digit. If I pick the first digit, I have 12.3. Now, if I then go to the next digit above, if I rounded this up, 12.3, if I round it up, I can get 12.4. Now the question is, this is 1 decimal place. That's true. But do I write 12.3 or do I write 12.4? It depends on the next digit. So if you have a look at the next digit, I've got my 3s, 12.3. That's my 12 and then 1 decimal place. But if you look at the next digit, that's an 8. Because the next digit's an 8, that's 38. So is 38 closer to 4, which represents 40 hundredths, or 30 hundredths? Very good. So the 38, because that's an 8, we can say 38 is closer to 40, or another way is the number bigger than 5. If the number is 5 or more, that's when you round it up. That's why it's closer to 12.4. So in this case, we can say this is 5 or more, so we choose this answer. So you have 2 answers there. Then you round it up. That's why this says 5 or higher. So if it lands exactly on 5, you round it up. And if it's anything higher, then obviously round up as well. Okay? Let's try the next one. So I've done the first example. Let's try the next one. 0.9761. If I ask you to round to 1 decimal place, what is the answer? Can I please have... Who have I chosen? I've chosen everyone on this side already. Well, let's go back to Quinn. All right, Quinn. Rounding this to 1 decimal place, what would you get?
Which is the 1?
Say that again?
Which is the 1?
Which is the...
The 1.
Which is the 1?
Yeah, it's the first one.
Oh, which was the first one? Okay, so here we go. First decimal, you can either get 0.9. 1 extra up is 1.0. Now, which one is this closer to? Is it 0.9 or is it 1? 1. Why? Because this number, next digit, tells you that's 97 hundredths is closer to 100 hundredths, yeah, which is 1 unit. Or 90 hundredths, which is 1. That's correct. Very good. 1.0 is just, I'm just showing you how you would increase this by an extra 1 unit. So yes, this is correct because this is 7, it's 5 or more. So hopefully you're seeing a pattern. You always pick the first digit, write it out, and then figure out what the next digit is, and you're going to choose between the two. Yeah, so here we go. Next one. You can choose either between 8.1, okay, because one decimal place, 8.1. Next one must be 8.2. Which one is it closer to? 8.14598 is closer to which one? Let's go, Rylan. Very good. 8.1 is the correct answer because this is 4. 4 is less than 5. Because it's less than 5, we stick to 8.1. You see the pattern? Okay, now, when we move to round to 2 or 3 decimal places, it's the same thing. So here, let's do it again. I'm going to rub all of this off. And I'm going to do the same pattern again. Here we go. I want 2 decimal places now. So after the decimal point, I'm going to pick 2 digits. So this one should be 12.38. 12.38. What's the next one after that? So if it's 12.38 as your basis, what's the next number that you're comparing with? 12 point. Well, I see what you're doing. You're choosing next digit. Yes, that's true. I'm trying to say next one up is 12.39. Get me? So I'm trying to say, can you see how I'm adding 1 to the first digit? 1 to the first digit. 1 to the first digit, 1 to the first digit. This one, because it's 2 place values, I added 1 to the 8, 1 to the 8. So you've got 2 to compare with. Now you're asking yourself, 12.384, is it closer to 38 or the 29? And the best way to know is look at the next digit. That's a 4. Now if it's 4, it's less than 5, so it's closer to 12.38. Very good. Got that sense? Okay, so what I want you to do now, I'm going to give you 2 minutes. I want you to fill out the 5 remaining spots and then round it all to a whole number. Okay, so you've done 2, 3. Once you've done that, I want you to do whole numbers and then you can move on to the exercise. But I'm going to walk around and check if you got these 5 correct. So I've done now 4 examples. I want you to try and get these 5 correct. That's the second skill I'm looking for. Okay, once you're done those examples and I come around and I check it off, then continue on to exercise 3C, negative fractions, or exercise 3E last week, multiply, add, subtract, and divide decimals. Okay, you got your questions to work on. You know which ones to do. Work on fluency skills first, that's minimum. Problem solving, if you can push this up. Yeah, so 3C, 3F. If you're up to date, it's 3F. Yeah? Here we go. So I'm going to write it over here. Move on to exercise 3C. If you've done that, it's 3E. And you know the fluency is the minimum. Fluency questions. I'm going to pause the video.